sun shining right on your hand. Okay, so if we have a linear scenario, okay, we know what a linear equation looks like. Y equals mx plus b. Okay, if we have an exponential, okay, we know that that can be y equals a times b to the x. What else is an example of an equation for exponential?
Oh, isn't it a y equals a plus y plus b?
Yes, good. Or we could have 1 minus p to the x, okay? So those are all exponential options. Now, it says keywords for linear models. And I don't know if I'm necessarily going to give you specific keywords all the time, but I am going to tell you how you can identify if it's linear, okay? If something is linear, we're adding the same number over and over and over again. Do you remember when we talked about slope?
Yeah.
And we talked about, it's one thing that just keeps reoccurring and reoccurring. We keep adding it. Do you remember that?
Yeah.
Okay, so addition is one of the things you want to put in here. Okay, we're going to keep adding something over and over and over again, and that's going to be our slope.
She's such a grown up, you have to get me.
All right, she does. All right, keywords for exponential models. For exponential models, there's a lot more keywords here. Okay. First, we can see that this is multiplication. Do you remember when we did y equals a times b to the x and it said like doubles or triples? Do you remember that?
Yes.
Okay. So that's one example. Actually, we can probably put halves in there as well. We could do half, and if it halves, that's it.
Oh, and she said don't scream.
So I'm doing it. I'm gonna be like embarrassing mom.
Oh my god, this is the worst.
They need us to work.
No, what's worse than dad? Okay, like no, like games and stuff, like it's not like that. Like concerts and stuff, and girls on stage, people go like whoever.
If my husband was there, he would be like,
that.
you are not saying anything. So since he's not gonna be there,
Our dad doesn't get nothing. He's just trying to get the whole time. And he also
okay, we're back together.
He would.
All right, so those are kind of the two big things I want you to look for. Is are we adding something over and over again, or are we multiplying over and over again? Okay, so that's kind of what I would look for there. So let's kind of just dive in here. So number one, your lawn is growing 1 inch every week. It is currently 4 inches long. So let's talk about that 4 inches long. Okay, if we have an exponential or a linear, can we agree that both of those equations have a starting value?
Yeah.
Called a y-intercept? Yes. Okay, they both have a y-intercept. In this case, our y-intercept is 4. Okay? Now, your lawn is growing 1 inch every week. That is our rate. Now, if it's growing 1 inch every week, are we adding an inch every week, or are we multiplying by an inch every week? Adding, right? Like if we have week 1, we add an inch. Week 2, we add another inch. We add another inch. So since this is addition, it's going to be linear.
But either way, it's the same.
What do you mean?
Timesing and adding 1.
Well, yeah, I see what you're saying there. If it was 2 inches, we would be multiplying.
But if it's 1, adding and multiplying is the same thing, definitely.
Okay, so if we have, well, kind of. If I had an initial value of 4, week 1, and then week 2, if I multiplied by 1, I would have 4 times 1 is 4. But if I added 1, I would have 5. You know what I mean? Yeah. So I see what I see where you're going there. Okay. So we have y equals 1x plus 4. 1 is our slope or our rate. 4 is our initial value. You tracking with me? Beautiful.
Stay tracking.
Okay. What'd you say?
I said stay tracking.
Stay tracking. All right. The pine tree in your backyard has 20% more pine needles every year. Guess what Mrs. Krasser forgot?
Pine needles? Percent.
She forgot to tell you the percent for an exponential. You already knew that. Okay, well, let's go ahead and write that in there. We can also have percents in there. Okay, so we can have doubles, triples, halves, or we can have a percent. So as soon as we see that there's a percent, guess what it is? Exponential. Okay, as soon as you see a that is an exponential. Okay? It says that there's 20% more pine needles. Is that increase or decrease?
Increase.
That is increase. So we're going to use this model right here. Okay, so we're going to use our increasing model. What is our starting value? 240,000. And then we're at 1 plus because it's increase. And 20% can be written as 0.20 to the x top. Okay, and what does that power usually represent? Time, some kind of time. In this case, it's year, because it's every year. So in this case, it would be years. Okay, number 3, the amount of homes in your neighborhood has doubled each of the last 3 years. When the neighborhood started, there were 3 homes. If it's doubling, is that linear or is that exponential? That's exponential. Doubling means some kind of multiplication. What's our starting value? 3 times what? If it's doubling, we're multiplying by 2. So 3 times 2 to the power of x. Okay, in this case, what would x represent? Years. It'd be years. All right, number 4, your cleaning lady charges $50 plus $10 per room to clean your house. So is she adding $10 for every room, or is she multiplying by $10?
Wait, is it 50 in parentheses 10 and then the x?
Well, we have to talk about, is it linear or exponential? Because if it's linear, it's not that kind of equation. Right? If it's linear, it's going to look like this. Okay, so if it's $10 per room, that would be 10 times x, but that means we're adding $10 for each room that she cleans. We're not going to be multiplying by 10. Right? We're not going to take that $50 and then multiply it by 10 for every room. You know how much money that would be?
A lot.
Woo! That's a lot of money.
That'd be like
Okay?
500.
I think I could handle adding 10, but I don't know about multiplying
That
by
means
10.
you can get a heck of bang.
Yes. Okay? And then that initial value of $50 is kind of that y-intercept there. Okay? That's her starting value.
What if
So
you
then,
don't do good? You just put it
in this case, it was, yeah. So, yeah, you know, sometimes it's trial and error.
Even if you don't even clean your rooms, you still gotta give $50 on it.
Yeah, because that's probably just like her, like all of the cost for bringing her materials there. You know, cleaning materials cost.
Why did you hire a cleaning lady if she wasn't going to clean?
No, but like
But
when
she's
she
saying like if she didn't clean the rooms, like that's probably if she like maybe came and did one room, like the living room or something. Okay, number 5.
or if she came there and she was like, oh, maybe I don't want to clean the house no more, and she got the money already, and she was out of it. But what they
I know
do,
it's weird.
Like,
it's Billy Bob. He opens all the doors every time.
Okay, number 5. Every year, the sports car in your driveway is worth half of what it was last year. You bought it for $85,000.
Sick.
So,
going down.
so that's my question. Is it increasing or decreasing in value?
You gotta put one half.
It's decreasing because think about it. If you have $85,000 and it's the next year it's worth half of that, it's worth less. Do we agree? Okay. So, what do you think? Exponential or linear? Why do you say exponential?
Because some happen by now.
Right, it's half. Good. Okay, so we'll have y equals our $85,000 times 1/2 to the x power. How do I know that I do the y equals ab to the x instead of a percent equation?
Because there's no percent.
There's no percent, right? It didn't tell us a percent. It told us half. So we use half there. Now, how do we know that this is decrease? Okay, good. What did I tell you in the first day of notes when we talked about is it increases? Yes, 1/2 is less than 1. That means it is a decrease. Oops, that means it's decreasing. Okay, so remember, if that rate is lower than 1, you have a decreasing. Okay, let's look at some tables, because sometimes you won't just be given a written question, you'll be given a table, and you have to decide. So if you look at a table, the values below shows the cost of your tree trimming service each year since you moved into your house. Is this linear or exponential? Well, let's decide. How do I get from 55 to 59? Plus 4. Does that work here?
Yeah.
Sure does. What about here? You bet. Okay, so we're adding 4 each time. If it's addition, what are we talking about? It's linear. Perfect. What is our slope? Yes, positive 4. And what is our initial starting y-intercept value? 55. Okay, we find that right here. That's our y-intercept. All right, number 7. The table of values below shows the number of rabbits in your yard over the last few months. How do I get from 4 to 8? Plus 4. How do I get from 8 to 16? Plus 8. That's not, okay, so let's talk. That's not adding the same amount. So do you think it's linear? No, because we can't add the same amount. So what's another way we can get from 4 to 8? Times 2. What about from 8 to 16? Yeah, look at that. If we're multiplying, what do we have? Exponential. Okay. So y equals your starting amount. Okay. What is my rate here? 2, because I'm doubling. I'm multiplying by 2 each time. Okay. And it's not a percentage because there's not a percentage. I'm just doubling.
How do you divide by 3?
Dividing by 3.
Oh no, 1/3.
Okay. So, how do we get from 27 to 9? Focus, please. Last question with me, and then you're going to practice here. What do we do? Divide by 3. Does that work here? And here? You bet. Okay, so if we're dividing by 3, that's not multiplication. But we can change dividing by 3 into multiplying by 1/3. That's our rate. Okay, so it's exponential. So our starting value is what? No, our starting value is 27 right here, okay? Times 1/3 to the x power. Okay, I want you to work on the practice. We're going to do it up here for Candy here in a couple minutes. Okay, so go and work on the practice, and then I'll have you come up.